Alright, hi everyone, welcome to my YouTube channel, City Collections, and this is the last past question of this course. So, I'm supposed to have a picture here of the circuit diagram, but it's really blurred, like extremely blurred, so I haven't tried editing it, but let's just work with this, okay? So, the following parameters are extracts from the datasheet of LM317T. 317T. That's adjustable three-terminal voltage regulator. You know, we've talked about voltage regulator in one of our previous videos. So this is just an extract from the datasheet. Now, all these values are gotten from the datasheet of the adjustable three-terminal voltage regulator. Datasheet is just a file or document or something, of course, write-up that contains information about a particular component. Okay, so these are gotten from it. Now, what we have to do is to what? Really discuss the functionality of the circuits with emphasis on what? Switch 1, S1, switch 2, S2, F1, which is fuse 1, LED 1, light emitting diode 1, then D5, diode 5, then X1, transformer 1, and then the red line. Hence, states the input voltage range of the LM317C. Okay, so let's go. Now, the first thing to understand, the circuit shown, I don't have that circuit here, okay, but understand that that circuit is what? An adjustable voltage regulator. Adjustable regulated DC power supply using the LM137T. So the idea is this: since all these things are coming from a voltage regulator circuit, we are asked to discuss the functionality, right, and emphasize on these things. So the question is kind of in two parts for us. One, laying emphasis on these parts of the voltage regulator, adjustable voltage regulator, and the second one is to second part is to state the input voltage range. Okay, so let's start with this part, stating the functionality with emphasis on these guys. This is the first part. I think I should highlight this first part. Alright, and then second part, or a different color. The second part, yeah. Hello. Okay, whatever. Now, so now look at it. So for S1, like I said, it's anything when you see S, no, you are talking about switch. Okay, so switch, which is S1, which is on and off switch. So S1 is the main power switch. The function is to connect and disconnect what? This AC supply. Connect and disconnect. Don't worry about this value, but just know that it's to connect and disconnect the main supply from the circuit. So when S1 is closed, current flows into the transformer. When S1 is opened, the entire circuit is switched off. S1 is our main switch. That's the idea of S1. That's functionality. Then for F1 is a fuse. F1 is a protective fuse connected in series with the input supply Now, what is the job of the fuse? To protect the circuit against what? Overcurrent or short circuit condition. If excess current flows, this fuse what? Melts and disconnects the circuit from the main supply. So in this way now, the other parts of the circuit is what? Protected, because this guy, the fuse will just melt off and the whole circuit is disconnected. Then X1 is what? Our transformer. X1 is a step-down transformer, and the function is to what? Reduce the 230 volts AC main supply to approximately what? 24 volts AC. Okay, step-down transformer. Then it also provides electrical what? Insulation between the main supply and the circuit. Right. Now for D1 to D4, anything once you see D, just know we are talking about what? Diodes, and they act as what? Bridge rectifiers. So the diodes D1, D2, D3, and D4 form a bridge rectifier, and the function is to what? They convert that AC from the transformer into what? Pulsating DC. Are we getting it? Then what happens next? During the operation, during each half cycle of AC waveform, two diodes conduct. The output polarity remains constant, producing what? DC output. So that's how it works. When the AC is like this now. AC goes let me just quickly do that. So AC goes like this, right? Alternating. So for look at this thing now. During each half circle of AC. So this is one half, this another what half. So during each half AC, what am I saying? During each half circle of the AC waveform, two diodes conduct. Meaning at this half, just two diodes will conduct. Okay. Then the output polarity remains constant, producing what? DC output. The whole idea is that these diodes, four diodes together, give us what? Bridge rectifier, and they what? Convert this AC. They convert AC voltage from the transformer into what? Pulsating DC. Okay. Then lead one, which is LED one, light emitting diode, and it serves as what? Power indicator. So the LED one is the power indicator LED, and the function is to what? Indicates that the circuit is powered on. So once there is power in the circuit, that LED will do what? Turn on. Then the other thing is when DC voltage is available after rectification, LED one also what? Glows. Okay. Then other one acts as the current limiting resistor for LED one. Of course, when using LEDs, you have to include resistors to protect the LED so it doesn't get damaged or things like that. Then C1 and C2 are capacitors. Whenever you see C, no, we're talking about what? Capacitors. And what their job is to what? To act as filters. So they are referred to as filter capacitor. The function is what? They smooth the pulsating DC from the bridge rectifier. They reduce ripple content and provide smoother DC voltage to the regulator. Now, for the IC1, this is the LM3170 voltage regulator. So the IC1 is the LM3170 adjustable voltage regulator, and the function is to do what? It provides a stable and adjustable DC output what? Voltage. Now the output voltage can be varied between what? 1.2 volts and 37 volts using resistor network and potentiometer. So the regulator maintains constant voltage, output voltage, despite changes in input voltage or load current. Remember we talked about other kind of voltage regulators in other of our videos. So we say we have 7, 8, 0, 5, 7, 8, and 0, 9. We've talked about different voltage regulator, where this one is a positive voltage regulator and it's giving out what? 5 volts. Positive voltage regulator giving out 9 volts. Okay, we did that in one of our videos, this same series of this course, past question. So for this particular voltage regulator, it is not like set to one output voltage, always 5 volts or always 9 volts. You are the one to adjust it. So one voltage regulator can give us within the range of what? One voltage regulator can be varied between what? 1.2 volts and what? 37 volts. Meaning we can have 1.2 volts as the output voltage. You can have 1.3, you can have 1.4, you can have 2, you can have 3 volts, you can have 4 volts, up to 37 volts. So we can adjust the kind of output voltage we want, unlike the other voltage regulators where our output voltage is always what? 5 or always 9 and so on. Do we get the point? So of course leave comments in the comment section if you have any question and things like that. Now S2 means what? Selector switch. S, where you see S, anywhere you see S, now we are talking about what? Switch. So S2 is a rotatory selector switch. And what's the function? It selects different resistor values connected to the adjustment terminal of the what? LM317 T. This changes the output voltage level of the regulator. So how come we are able to adjust the output voltage of a voltage regulator? Is because we have what? This selector switch. Okay, we have the selector switch. Now D5, I said that anywhere we see D, we're talking about diode, right? So D5 is what? Is what? The protection diode, and it's connected across the voltage regulator. The function is to protect the LM137 against, the LM317T against reverse what? Current. When power is turned off, it prevents capacitor discharge current from flowing backwards into the regulator. You know, diodes are components that allow current to flow in one direction. Okay, so this is let me do that better. So so we have it like this. Okay, this drawing is too funny, but you understand what I'm trying to do now, please. Please manage to understand. What I'm saying is this. Okay, I think it's a better way to draw it. Yeah, diode. Okay, so diode allow current to flow in one direction. So once we add diode to this circuit connected across the voltage regulator, when power is turned off, it prevents capacitor discharge current from flowing backwards into the voltage regulator. Of course, it prevents current from flowing backwards because diodes allow current flow in one what? Direction. Okay. Then the red line represents the positive DC rail of the circuit, and the function is to do what? Carries positive DC voltage from where? Rectifier stage, filter capacitor, regulator stage to the what? Output terminal. And it is the main positive current path in the circuit. Okay, so this is just the whole thing about this first part. Okay, and we've already handled more than what we have here. Okay, so now to state the input voltage range. Before we talk about the input voltage range, note that, look at this, input voltage should be what? At least 3 volts higher than the desired output. Okay, higher than the desired output. What is the output? Look at it. The output is what? From 1.2 volts to 37 volts, right? And the input voltage should be what? At least 3 volts. Meaning the range of the input voltage should be what? This plus this 3 volts plus 1.2 volts to 3 volts plus 37 volts. Look at it. Look at this calculation here. So input voltage range of the LM3170. So from the given specifications, the input voltage should be what? Greater than or equal to output voltage plus 3 volts. That's what we have here. Should be at least 3 volts higher than what? The desired output. So now say it is V in, that's the input voltage, should be what? The V out plus what? 3 volts. And the V out is what? Look at this. The output voltage is 1.2 volts to 37 volts. So V out 1.2 volts to 37 volts. That means our maximum. What's that? Sorry, this is minimum. This is minimum. Okay. What we have here is what? Minimum. And there should be what? Maximum. So you look at it. This is the minimum now. This is the minimum. So that would be what we have here. Okay, that's the minimum. Then this guy is the maximum. So that will be what we have here. That's why you see 37 plus the 3 volts. Then this one is what? 1.2 plus the 3 volts. So this is our maximum voltage, and this is our minimum voltage and our maximum voltage. So hence the input voltage range of the LM137T is approximately what? 4.2 volts to what? 40 volts. So when you see that voltage regulator now, the input voltage you can give to it, okay, the range of voltage you can input into that voltage regulator should be from where 4.2 volts to 40 volts, because our output voltage is going to be what, from 1.2 volts to 37 volts. Okay, exactly. So that's it for this whole thing. Okay, so with this we are done with all past questions in this course, and of course, like, share, subscribe, and we'll see you in other videos. Thanks for watching.